On this question, we're given the formula for the volume of a cylinder, and we're told that the radius is 6 and the height of the cylinder is 5. And this is all given in the diagram as well. So what we need to do first is to construct an equation for volume. And what we're going to have at the end, if you read further, it says, given the weight of a cubic meter of water is 2,205 pounds, we're looking for the weight of the volume, which is basically like a density formula. So let's put this together. The radius is 6 squared times the height, which is 5, times pi. Rearrange the formula. I just prefer to have it this way. It doesn't matter. Hopefully we're going to put this whole thing in our calculator, let it do the work for us. So we put that in, and it's going to tell us that the volume is 565.48. Don't adjust your calculator, just keep that number in there. And since we are trying to find the density, we need to multiply the volume times the weight of the cubic meter. On these, you do notice it does compare meters to meters in the top and bottom. Double check that always. But when we do this, what we learn, this is not volume anymore. This is a density. So the density would be 1,246,898, which is J. So in this question, what we could do is create the system of equation. There's a how many and a how much formula. There are a group of 21 people, and it's children and adults. So we could say children plus adults equal 21. That's our how many, and our how much equation would be $4 per child, $6 per adult, for a total of 90. I would suggest if you were going to do a system of equation that you use the reverse row echelons form. And don't forget, some of you that might have a newer calculator, underneath apps, there's also a system solver. What I'm going to do instead is this. It tells us what is the ratio of number of children to adults. Well, let's talk about what we have. We have 21 people, so how could we divide this up where it hits any of these ratios? I could have 1 child, 21 adults. Oops. No, I couldn't. I could have 1 child and 20 adults. It's a 20-to-1 ratio. There would be 2 children, 19 adults. Again, that ratio doesn't match any of these. 3 is to 18. So that does match the ratio 6-to-1. So let's see if this equation works. 3 children times 4 would be $12. And 18 adults, 6 times 18. And I'm going to do both versions of this. Is 108, so that's way too big. Let's reverse the numbers, though. Let's say that there were 18 adult children, and 4 adults, or 3 adults, And that does equal 90. So that would be our correct answer. So I'm going to show you this one by hand, and then I'm going to show you a nice little calculator trick that you may want to do. Anytime I have a negative exponent, the first thing I do is just flip everything so I can get rid of the negative sign. So I'm going to put the 8x to the negative 2, y to the 6th, z to the 3rd in the top, and I'm going to put the 2x to the 3rd, y to the negative 5, and z to the 8th in the bottom. When I make this reciprocal, then I can drop the negative sign from our powers here. I also like to solve everything on the inside. Remember, when we are dividing, we subtract these values. And you can also move these. I prefer to move these down. So the values that have a negative exponent need to be moved to the other spot. So we have a negative x, we have a negative y. So I'm going to just reverse those around. So the 8's going to stay put. The y to the 6 is going to stay put. And let's go ahead and cancel these z's while we're at it. We can cancel 3 of the z's, which would leave 5 z's in the denominator and none in the numerator. So these are the values that stay where they're supposed to. While we're at it, why don't we go ahead and reduce this? 8 divided by 2 is 4. So there we go. The y to the 6 stays where it's supposed to. The x to the 3rd stays where it's supposed to, and we still have a z to the 5th power in the denominator. Now at this point, we're going to move these. So y to the 5th power, negative 5th power, would be a y to the positive 5th power in the top. And the x to a negative 2 power would be an x to a positive 2 power in the bottom. So this would leave us with 4y to the 11th over x to the 5th, because when we multiply numbers, we add their exponents. And this would be z to the 5th. You probably could look at the answers here and see which ones of these are even set up right. For instance, this one doesn't have x's and z's in the bottom, so it's wrong, but it probably looks like the correct answer. That would be something worth looking at. But I'm going to mark it out because I know it's not right. This one also doesn't have x's in the denominator. This doesn't have a z. This doesn't have a z. So I really don't even have to go any further. I have my answer here. This is also one of those you can use as a study guide for later in the test, because when we have powers to a power, we multiply their exponents. But 4 squared is 16, y to the 11th power squared is 22, and then the x and the z would both be 5. 10, excuse me, I'm sorry. 5 times 2 is 10. So I'm going to show you a little trick here that I know. We talk about this in my class a lot. Numbers are going to do what they're supposed to do. So we can see that we're obviously going to end up with a 16. The question is it going to be in the numerator or the denominator? So I would say this, if I were using my guessing technique, since 3 of them are in the numerator, I would think my answer is going to be 16 in the numerator. But let's just take a look. So what I'm going to do is pretend like there are no variables in this equation whatsoever. So I'm going to go alpha y equals, do the fraction mode of 2 over 8. Forgot my parentheses. And I'm going to put this to the power of negative 2. Make sure you use a negative sign, not a subtraction sign. So when I do this, I hit enter. I can see that this is 16, not 1 over 16, which means answers H and J are off the board. Now I can do the same thing with my X's and Y's and Z's. If I treat them one at a time, here's what I mean. If I go to Y equals, and I'm just going to pretend like there are only X's here, and I put x to the 3rd power over x to the negative 2 power. Now, if I were smart, I would have looked and seen, are the x's different in all my answers? They actually, the g and k are similar, so we'll see. What I'm going to do is set this up exactly like the last one, and I'm going to take it to the negative 2 power. And what I'm interested in is this equal to x to the 10th power. And the reason why I chose x to the 10th power, because that is what F says. So let's take a look at their tables. So you see the tables are not exactly the same, so F is no longer an answer. Now let's just check this real fast. It's going to make sure that the other one is correct. Since x is in the denominator, it is 1 over x to the 10th power. And if this proves to have an equal table, well, that means that the answer is G or K. And you can see that those tables match identically. So the only question is on G or K is, where is the Z supposed to be? Because their Y's are exactly the same. So we can do this as well and check our Z values out. Now, I hope at this point you'll recognize the math that's going on and you can make these values the same. You can see the math that's taking place. But you see it's Z to the 8th over Z to the 3rd power. And we're going to see if the Z belongs in the denominator. So if this comes out to be an equal table, then I know my answer is K, because the K has the Z in the denominator, which is where I have it. So if this table matches, my answer is K. This composition function, I like to work inside out. So what this is basically telling me to do is to plug in -1 into the g of x function. And then immediately after that, I'm going to take the result and plug it into the f of x function. So I'm going to work inside out on this. So I'm taking the g of x function, which is x squared minus 1. And you better believe you're going to be plugging in negative numbers into a squared value. So be ready for that and use parentheses. If you put this in your calculator like I have this written right there, your calculator is going to tell you -1 because you gave it the wrong information. So let's take a look at this. We put this in parentheses, -1 squared becomes 1. So the output value for g of -1 is 0. So what we do with this 0 value is we immediately take it and put it into the f of x function. So this is f of 0, which is 2 times 0 plus 3. The f of 0 would be 3. So that would be our solution, 3. This is a probability question. It says, in a window display at a flower shop, there are 3 spots for one plant. To fill these 3 spots, Adam has 7 plants to select from. Each is a different type. Selecting from 7 plants, Adam can make how many possible display arrangements with one plant in each spot? So this is a topic that we have not covered in statistics yet, but there's a thing called a permutation, and it's a button in your calculator. If you go to math and then you hit over 4 times and go to PRB, that's probability. It is the second option in there. Now the way you would do this, you would have to actually first type a 7 and then type math probability, and then it's going to pop up there as NPR, and then we would type a 3 behind it. And what this is basically saying, you have an option of 7 options and we're filling 3 spots. Here's another way we can practically do this. As he's filling this plant order, the first one, he has 7 different options he could put in. Now when he moves to the second slot of the 3, he only has 6 options at this point because he has the first plant sitting in the thing, in the first slot. And now when he moves to the third slot, he only has an option of 5. So what we do, this is just multiply the number of options that we have. 7 times 6 times 5. 7 times 6 times 5 is 210, which is our correct answer. So on this one, we're looking to make a permutation. I do believe this on newer calculators, there's an app or something on these, and it may be one of the function buttons, but I don't have it on this program here. So we'll have to do it the original way I was taught. So we have a 7 permutation on 3, so we hit 7. And what we're going to hit is math, and we're going to scroll over to the probabilities, and there is our permutation. When we hit this, it's going to look like that. And since we are dealing with 3 slots on the window, we put the number 3 in here. And then we simply hit enter, and there's our answer. So in this one, we're trying to find the area of this quadrilateral, and this quadrilateral is a trapezoid. A lot of times the information that's at the beginning is just describing what you see. So read the last sentence and see if you can solve without reading the others. If you just need to read, you go for it. But when we're doing the area of a trapezoid, what you need to know is this. I look at it this way. We really have to do the middle times the height. And the middle line is going to be the average of the other two. So we could sit here and create a formula and say 28 plus 20 divided by 2. But if it's 28 and 20, the halfway point between those two is 24. Essentially, if you were to take a trapezoid and you were to cut this little piece right here, it would fit together and create a rectangle in this spot. So all we need to do is multiply the height, which is 7, times the average or the middle of this trapezoid, and that would give us our answer, 168. All right, so we're just going to go with a basic formula for this. This is a triangular prism. Just remember this, anytime you're doing volume, the generic solution for a prism is the base area times the height. So if we find the area of the base, which in this case, like we said, is a triangle, and we just multiply it times 10, we will know the volume. This is any shape. If it's a circle, cylinder, you find the area of the base and you multiply it. Because essentially what we have is 10 of these triangles stacked up together. That's what we're talking about on volume. So we're going to go and find our base area, which is 1/2 base times height. Half of 6 is 3. So 3 times 3 is 9. So the area of our base is 9. And we basically have 10 of those triangles stacked up together. So our volume is going to be 9 times 10, which is 90 cubic feet. All right, as we take a look at this, it says a rectangle, that has C inches by D inches is in the interior of a rectangle that is A by B inches, as shown below. The area of the shaded region is what fraction of the area of the larger triangle in terms of A, B, C, or D? So when we look at this, we are basically trying to find the shaded region, because it says what fraction is the shaded region of the entire triangle. So what we need to do is find the shaded region. Well, the shaded region is the area of the big triangle, that's A times B, minus the area of the small triangle, which is C times D. So that is what our shaded region is. And the area of the entire triangle is just I keep saying triangle, I mean rectangle, I'm sorry. The area of the entire rectangle is just A times B. This would be our answer choice, A. Here's another question kind of dealing with the fundamental counting principle. It says a company prints contest codes, fun-sized bags of candy. Each 6-character code consists of the letter A. We don't have choices there. There is one option that we can have for this one. That's the letter A, followed by the letter H. Well, we have one option for this. Now, the following 4 are any digit between 0 and 9. So we have 4 spots to fill. And it does say the digits may repeat. So if we're looking at this, we have 10 options for the first, 0 through 9. We are not we are allowed to repeat, so we still have 10 options for the 4th digit. We have 10 options for the 5th, and we have 10 options for the 6th value. So we can see This is our answer F. This is a question you make sure you pay attention to what you're answering. It says the mean of the daily temperature of 5 days, that's important information, 5 days, for a certain city is recorded for being 4 degrees Fahrenheit. It was later determined that the high temperature for one of the days of the 5 is recorded incorrectly. If that day's high temperature was 2 degrees higher than the original recording, what was the difference? Here's the part we got to watch. What was the difference between the incorrect recorded mean and the correct recorded mean? Well, what I'm going to do is I'm going to figure out, so the average, the mean, is to add them up and divide by the number. So I'm going to just treat it as if every day was exactly the same. So if we had 5 days with a 4 degrees Fahrenheit measurement, that means it would total 20 degrees Fahrenheit. That's every day being 4 degrees. But what we're told is if the day's high was 2 degrees higher than originally recorded, well, instead of this being 20 degrees Fahrenheit, one of those days, it doesn't even matter which day, is going to be equal to, make our total up to 22 degrees Fahrenheit. So our total is 22 degrees Fahrenheit. We're going to divide that amongst 5 days. So when we take 22 divided by 5, we get 4.4. Don't get too excited. Choose E here because remember what the question asks. It says, what was the difference between the correct and incorrect mean? Well, that would be 0.4 degrees Fahrenheit because we originally had a 4 degree Fahrenheit and then we had a 4.4 degree Fahrenheit. These answers might even give that one away a little bit. You should know that it's not going to remain the same by changing a temperature would not stay the same. And then the fact that these two answers are the difference between 4, that's a good sign that those are 2 correct answers. Not 2 correct answers, but an answer that is pointing to the correct answer. So as we look at this, I hope that we do a little bit of illustrating. Make sure you're writing on your sheet of paper here. It says a box containing 6 objects. Of these, there are 3 discs. Draw little circles here. 2 of them are blue, and 1 of them is red. And it says there are 3 triangles, 1 of which is blue, and the 1 is red, and 1 is yellow. What is the probability, if the probability of drawing each object is the same, what is the probability that an object is drawn is blue or a triangle? Well, we have 1, 2, 3 blue objects, and we have 1, 2, 3 triangles. So that's a total of 6. But if you look and see what we've done, we've counted the blue triangle twice. We counted it as a blue object and we counted it as a triangle. So when we have to subtract any overlap that we have. These are not mutually exclusive. So we will have to subtract this back away. So 3 plus 3 is 6, minus 1 is 5/6. That is our probability of selecting, a blue object or a triangle. I'm going to show you how we can use this one on the calculator. I would strongly suggest using that, but don't forget we can use that spiraling that we do and convert this into an exponent, which is 4 to the negative 3 power equals x. So all we get to do on this is put in our calculator 4 to the negative 3 power. Remember, negative exponents do not make negative numbers. What they do is they make fractions, and 4 to the 3rd power is 64. I will show you how we can graph this or put this in our calculator and check our answers. but I think if you make the conversion, you will get done a little quicker. What we're wanting to do is find the log base, and we can plug in our values to get this. This is not a good one to do y equals on because my multiple choice answers were all over the place. 1/64 is hard to find, so it's 1/12. So I'm going to plug in the values and see which one that it is. So if we hit alpha, F2, this is where we find our log base. This is where we find our log base. So I'm going to plug in the number 1/12. So it's log base 4, and then we have 1/12 is the plug-in value. So if this is the correct answer, when I hit enter, it's going to say -3, which it does not. So you can also save yourself some time by hitting second entry. It's going to pull up the last thing you put. And since we're already in fraction mode, let's just type over the 12 with the 64. And then we hit enter. And you see this comes out to -3, which is what we were wanting it to come out to. So there's our correct answer. So as we take a look at this, I'm going to talk about the graph and a phrase that you may not be familiar with. It says the whole number test scores for all 30 students in Miss Smith's class are represented, and here's the word, a cumulative frequency bar on the graph below. When you think about a cumulative frequency, I think of it like people holding their hands up. It's like, okay, how many of you, are this score? Keep your hand up until I get to your score. So people are not putting their hands down. As we move up the line, you keep your hands up until everybody's hands up. That's what a cumulative frequency is. So as we look at these, it even tells you on the bottom, these are our values between 41 and 70, 41 and 80, 41 and 90, so on and so forth. So it says in our equation, in our question, excuse me, it says how many students in Miss Smith's science class had a score greater than 70 on the test. So as we look at this table, instead of trying to calculate how many had over a 70, what I would rather do on a cumulative frequency is to see how many people had test scores lower than 70. So as I slide this over, I can see these are my from 41 to 70. That's all of these added up. See, this is 2. Well, this is the 2 plus an additional 3. That's how a cumulative frequency is. This is 2 plus the additional 3, and then that takes us to 10, so that would be an additional 5. That's what a cumulative frequency is. So when we get to the 70, there are 10 students that did not score higher than a 70. So if there were 30 students and 10 did not score higher, that means that 20 did. So this question says, which of the following intervals must contain the median? Remember, the median is the middle score of the students. So we had 30 students. So that would be, the median score would be the 15th student, which is where this line crosses here. And you can see that that does not hit exactly at any of these intervals. What it is doing is it's happening between 70 and 80. So the interval that the median would be taking place would be somewhere between 71 and 80. Because the median is the middlemost score, and these are basically in order, so halfway between 30 would be 15. And on this example, it says the students in Miss Cho's class took the same test as Miss Smith's class. The number of students in Miss Cho's class with a score from the range of 41 to 50 was 3 less than 4 times the number of students in Miss Smith's class with the score in the same range. How many students in Miss Cho's class had the score in the range of 41 to 50? So what we need to first do is identify how many students had the score from 41 to 50 in this class. And luckily for us, it's the very first option. So 41 to 50 would be 2 students. 2 students from Miss Smith's class. So the value we're looking for, Smith's class, is 2. And it tells us that Miss Cho's class is 3 less than 4 times Miss Smith's class. So since Miss Smith's class was 2, we multiply that times 4. That gives us 8. And we subtract away 3, and we get 5, which is F.